there. All right, so here we are doing our last lesson, our last set of identities that we're going to learn. Today we're going to do half angle identities, and let's just jump in. So these identities will enable us to find exact values of angles, of angles that are half of some of the angles that we already know. For instance, if you could find the exact value of a 15-degree angle because it is half of a 30-degree angle, and we know what the values on a 30-degree angle are. So that's kind of the mentality on this. Now, you can see the formulas here. They are the sine of, for instance, if I was doing a 15, so then I would do a 30 right here because 30 divided by 2 is 15. But then within the identity, I'd be doing the cosine of 30 because I know that one from my unit circle. All right, so the sine and cosine identities are very similar. The sine uses subtraction, the cosine uses addition. It's the only difference there. Tangent looks a little bit different and actually is sometimes nicer because you don't have to battle with that radical in there. Now, the one thing that is a little bit confusing with the way that these identities are written are these plus or minuses that are here. That doesn't mean that there's two possibilities. You don't have a plus and a minus as an answer. It just means that sometimes it's going to be a plus and sometimes it's going to be a minus, and you have to have an awareness of where this half angle would land. Where would the 15 degrees land? And it would be in the first quadrant, so the sign should be positive. But if I was doing something else and the half angle, not this angle, not the alpha by itself, not the 30, but the half angle, the 15, wherever that lands dictates whether it's going to be positive or negative. All right, so let's do one here. We're going to find the sine, the cosine, and the tangent of 11 pi over 8. So the first thing is you have to figure out, well, what is that half of? And to do that, ultimately, you just double it to see what it would be half of. So if you think of an 11 pi over 8 and you double it, well, the 2 and the 8 would reduce. So an 11 pi, so I'll just write it over here. So it is half of 11 pi over 4. Okay. So 11 pi over 4, I know from my unit circle. I can figure out an 11 pi over 4. It doesn't feel like it's one that I should know or that's on there, but I can get there. So that means that 11 pi over 4 is what I'm going to use as my alpha within the formula. So I've given us a couple pages to do this in our notes. So I'm just going to do the sine on this page. I'll do cosine and tangent on the next. So I'm going to do sine. And ultimately, I'm taking 11 pi over 4 and I'm dividing it by 2 because that would be the equivalent of 11 pi over 8, which is my goal here, 11 pi over 8. But when I write that, I'm going to do this square root, and it's going to be 1 minus the cosine of just the alpha piece, the 11 pi over 4, all over 2. And then I have to decide, based on the half angle, what quadrant does that land in? And should my sine or my cosine be positives or negatives when I do that? So I'm going to come over here and think about this. An 11 pi over 8. Well, remember that, well, let me grab my pointer here. This is 1 pi, this is 2 pi. So you're really looking at the fraction 11 eighths. Well, 11 eighths is greater than 1 because this would be 8 eighths. And 11 eighths would be another 3 eighths. So you're going to end up like right here, somewhere in the third quadrant. So if I'm in the third quadrant, sine's going to be negative. So is cosine. So maybe you sketch for the sake of your notes that this is your 11 pi over 8 down here. And so sine and cosine are negative. So I'm going to distinctly put a negative sign in front of that radical then. The rest then is just powering through some algebra with that radical, a little bit of unit circle here, because you do have to figure out where is 11 pi over 4. That is not a natural one on our unit circle, but we could figure it out. If you just subtract 2 pi, you could get your coterminal angles. So 11 pi over 4, subtract 8 pi over 4, because that is 2 pi, and you're left at 3 pi over 4. So the 11 pi over 4 is just a coterminal angle with 3 pi over 4. So 1 minus the cosine of 3 pi over 4, that's a negative root 2 over 2. All over 2. So you can see you've got some nested fractions in here. So typically what we'll do is we'll immediately turn this 1 into a 2 over 2 so that you can get a common denominator. This particular one goes plus a positive there. So then I'm left with negative 2 plus root 2 all over 2 all over 2. Right? I'm just combining these, but then it's still over 2. What we do with this 2 here is we pop it up and we multiply it by its reciprocal, which is going to work out great. You can see why I gave us 2 pages. This takes up a little bit of space. I'm going to end up with a square root of 4. Actually, you know what? I better come up here. I'm trying to show you step by step on this. As you get better, you can start to do some shortcuts on writing every single step. But it gets to that stage, and then the denominator actually comes out nice. So I am left with 2 plus root 2 all over 2. And we actually do just leave it like this. I know it's a radical inside of a radical, and that seems crazy, but we do leave it as that. Now, make sure that as you write this, that it's very obvious that your 2 is no longer in that radical. Sometimes we get a little sloppy, and I can't tell the difference. Are you thinking that 2 is supposed to be in the radical? So make your fraction bar big enough to distinguish that. All right, that's my answer right there. All right, let's try it with cosine. All right, so I'm going to have the cosine of 11 pi over 4 over 2. I write it like that to reinforce that this is really the angle I'm going to be using. I've already designated that I'm in the third quadrant for that half angle, so I'm going to make it be negative, big square root, and I'm using the cosine. This time it's a plus, so 1 plus the cosine of 11 pi over 4 all over 2. The cosine happens to be also negative root 2 over 2. And this is going to be a 2 over 2 right here. And this is going to be all over 2. Now, that doesn't always work out just like this, but it does a lot of times because this root 2 over 2 that I wrote, oftentimes, well, it's going to be a root 2 over 2. It could be a root 3 over 2. It could be a 1/2. I have this common denominator of 2 almost every time. Then I'm left with, let me go ahead and condense, 2 minus root 2 all over 2. And then instead of dividing by 2, I'm going to multiply by the reciprocal, 1/2. That's just me bringing that up right there. Call it at 1/2. And then I'm even this time, like I said, as we do it more, I'm going to start recognizing how this is going to play out. This ultimately is a square root of 4 in my denominator, which is just going to be a 2. And in the numerator, I'm going to have that negative out front, square root of 2 minus root 2. Now compare that to what we just had on the previous one. Ultimately, this sign right here just changed. And that's really going to be the case. Well, I'm not going to say all the time because it doesn't. It's not going, we're going to do a problem here in a second where that doesn't play out like that. But it does, if you can kind of track it, you'll notice that there's very limited difference between the two. Okay, last one. Let's do tangent. All right, tangent is going to be 11 pi over 4 over 2. So I'm going to use the 11 pi over 4. It's going to be 1 minus the cosine of 11 pi over 4 over the sine of 11 pi over 4. So I got 1 minus, and remember 11 pi over 4 is just coterminal with 3 pi over 4. So the cosine at 3 pi over 4 is a negative root 2 over 2. But the sine at 11 pi over 4 would be a positive root 2 over 2. All right, let's change this to 2 over 2, change this to plus plus. I'm left with a 2 plus root 2 over 2. And it's divided by root 2 over 2, but I'm going to pop it up and multiply by its reciprocal. So 2 over root 2. I am going to get lucky here because these 2's are going to cancel out, but I'm still left with this radical in the denominator, and we don't like to leave that down there, we all know. So we're going to have to, keep changing the color there. We're going to have to rationalize this. So distribute that root 2 through. You're going to end up with 2 root 2 plus 2 all over 2. And just when you think, I'm almost done, nope, got one more step, because I can divide both of these nicely by 2, so I should. Final answer is going to be a root 2 plus 1, and I can put it over 1, but why bother with that? It actually comes out very nice, and tangent does that. You have to battle through all this rationalization and these radicals all the way through, and then boom, it comes out nice at the end. So I feel like we're doing as much algebra here, just practicing how to deal with rationals and radicals, as much as you are doing much with the unit circle, because there was kind of like this one step where I had to know what this was, and then the rest is all algebra. Okay, so I have one here. I'm going to get you started on it at least, and then I might turn you loose to let you finish it up. We're going to find the exact value of sine of 105. All right, so I'm only going to do one time here. I'm just doing this, the top identity. I'm not going to do all three this time. The first thing you have to do is you have to figure out, how do you write 105 so that it's half of another angle? Well, 105 is really half of 210. Remember that you can just take it times 2 to figure out what it is half of. Oh, it's half of 210. All right. So now here I am, sine of, and instead of doing 105, I write it 210 over 2, because 210 is going to be the angle I'm working with, because it's the one that I know from the unit circle. However, this is the big thing that people have to, that they tend to forget, is that when I'm finding this plus or minus thing, I am basing that off of the half angle, not off the 210, off the 105, because I'm ultimately finding the sine of 105, not a 210. So knowing where 105 lands, that's going to land in your second quadrant, so sine will be positive. I like to go ahead and put a plus sign here to indicate I made a conscious decision to make this positive. It's not that I just forgot that plus or minus there. I made a conscious decision. It is positive. If you were using the 210, I'm going to see that you put a negative there, and I'm going to know exactly what you were thinking. So I like that plus sign, so I know that you knew you're using 105. All right, here we go. 1 minus the cosine of 210 all over 2. Now, I put the plus sign there initially, but I don't need to keep putting it there. 1 minus the cosine of 210. All right, that is a negative root 3 over 2. All over 2. Change this to 2 over 2. Change this to plus plus. I'm left with a 2 plus root 3 all over 2. All over 2. But this 2, I'm going to pop up and call it times 1/2. So times 1/2. I'm going to be left with, notice the square root of 4 again in the denominator, because it's a root 3 over 2. So I'm going to have a nice clean 2, because the square root of 4 is 2. And then up here, I'm still going to have the radical caught up inside of the radical. And we just allow that to hold, because all we really care is that the denominator doesn't have a radical. We can make the numerator as ugly as we want. All right, did I say I was going to let you do that one? I forgot. I got excited and kept going. Okay, let's keep moving. Very short lesson today. Just a couple more slides. And I say a couple slides, but it's really one problem that we're going to do. It's just I gave you 2 slides to do it. So use the half angle identities to find the exact values given. All right, so now I'm stepping away from the unit circle, and I'm just looking at any random angle. I can do this same thing. If I know that the cosecant of alpha is negative 5/3, I want to find the half angle measurement, so alpha over 2, for sine, cosine, and tangent. To do this, we're going to draw some triangles. So I'm going to, it's kind of like when we did the sum and difference ones where we had to draw the triangles. Except on sum and difference, you had to draw two triangles because you had an alpha and a beta. We just have alpha here. Now this right here is going to tell you that what quadrant you're in. You're between pi and 3 pi over 2. That's down here in the third quadrant. So that's where I'm going to draw my triangle. Always draw out of the origin, straight back to the x-axis so that that is where your right angle falls. Now the cosecant, remember, is the reciprocal of sine. That means if sine is opposite over hypotenuse, this is hypotenuse over opposite. So hypotenuse is 5, opposite is -3. And then your job is to find the missing side. You can do Pythagorean theorem, but they do love to give us those Pythagorean triples. Hopefully you know by now that that's a 3, 4, 5, but it's not really a 3, 4, 5. It is 4, but you're going left. And that's the whole reason that they tell us this, and it's the whole reason we draw the triangle so that we get our signs correct on this. We are going left, so that is a -4 there. Now I'm going to work on the half angles. I'm going to do sine here. I'll do cosine and tangent on the next slide. So I'm going to do the sine of alpha over 2. Now I know that on the next slide I actually had sine, but I feel like I've got space here to do at least one of them, and that'll give me more space on the next slide to do cosine and tangent. All right, so the sine. Now, just like always, you have to figure out where the half angle is to decide the plus or the minus. Not the angle that I just drew, not the one that's in the third quadrant. I would have to figure out where half of this angle is. Now, it feels like, well, wouldn't that vary depending on where you're at here? It actually doesn't. If you had a 100, or let's say you had I'll just make numbers nice and easy. If you had a 200-degree angle that was just right here, half of 200 is 100. It would fall here. But even if you were way down here, like let's say at 260, half of 260 is 130. You're still up in the second quadrant. So the half angle, maybe make a note to yourself, because this right here is alpha. Well, and so I'm going to say that alpha over 2 is in quadrant 2. And if I'm in quadrant 2, then my sine is going to be positive. My cosine later will be negative. Right? And then you have 1, and the sine identity, you do minus. Oh, goodness. The cosine of alpha all over 2. So 1 minus, and I look at my triangle to figure out the cosine of alpha. Cosine is going to be adjacent over hypotenuse. So that's a -4/5 all over 2. Now this is what I was talking about. You don't always change this 1 to 2 over 2. In this case, I'm going to change it to 5 over 5 because I'm just trying to get that common denominator. Change that to plus plus, and I'm left with a 9/5 divided by 2, but bring that up and change it to multiplying by 1/2. So I end up with the square root of 9 over the square root of 10, which really the square root of 9 is just 3, so that's easy, but and I have to rationalize. So I'm going to be left with 3 root 10 over 10. Okay, let's see if we can do. Now, I also said that all you have to do is change your sign. And okay, this is you're dealing with numbers here, not just, I mean, adding a 4/5 and subtracting a 4/5 is going to get you totally different numbers. So it's not quite that straightforward on the how similar the sine and the cosine are, like it was earlier. All right, so I think I'm going to appreciate that I gave myself a little bit more space on this side. So I'm going to, well, I'm not going to draw a line yet. That'll probably not end well for me. Okay, so the first thing I want to do, cosine of alpha over 2. It's going to decide if it's a positive or a negative. and we decided that the half angle lands in quadrant 2, so that's going to make cosine negative. And then we do this big square root, and it's a 1. For the cosine identity, we're adding. So you add the cosine of alpha. Looking back at your triangle, remember the cosine of alpha was negative 4/5 all over 2. Now we change our 1 to a 5 over 5, and we have this negative is still here. That becomes 5/5 minus 4/5. That's a 1/5. Divided by 2, pop that up, same as multiplying by 1/2. So that's going to end up a negative square root of 1/10. I'm going to have to rationalize that, do root 10, and my final answer there then is going to be the square root of 10 over 10, with a negative on that, of course. Okay, let's try one more. Let's do tangent. I'm going to start up here. 1 minus, so from the triangle, cosine is negative 4/5. But now it's over the sine. So looking at your triangle, what's the sine of alpha? Opposite over hypotenuse is going to be a negative 3/5. Change this to 5/5, change that to plus plus. I'm left with, okay, I might go horizontal here. This is 9/5 divided by negative 3/5. Now, notice on the tangent, you don't deal with the plus or minus. Everything takes care of itself that you don't have to make that decision. So 5 over negative 3. Oh, this is going to work beautiful. Oh my gosh, look at this. I end up with a 9 over negative 3. My answer is just negative 3. That's crazy. Now, before I sign off here, I wanted to show you one thing, and you may have, somebody out there is wondering right now, like, can't you just find tangent since you now know what cosine and sine are? Because isn't tangent just sine over cosine? Well, let's see. Does that work? The tangent we said was 3 root 10 over 10, and that's sine over cosine, which is a negative root 10 over 10. If you bring this up, multiply by the reciprocal, these 10s cancel, these root 10s cancel, and all you have left is this negative times 3, and you get negative 3. So yes, you can do that. It's just that not always do you find all 3 of them. I'm just practicing all 3 identities. Sometimes you just have to find one. But if you're finding all 3 and you've already got sine and cosine, if you just want to do that, more power to you. All right. Get your homework done. Thanks for joining.